Okay, this problem called heap 0, it is asking about the concern of overflows. We know in stack we have a overflow, but in case of heap, is there any overflow, and how does this overflow thing work? So for that, we have to launch the instance to understand what is actually the question about. So let's just begin. Then it says we have to connect to the challenge using NC. Okay, let's copy it, paste the selection, and here it shows that this address holds a data and this address holds another data. Print the heap, it will print this heap. Write to buffer, so we can write on the top of the heap. Heap, what is heap? Heap is basically a dynamic memory. Okay, so uh, it contains data, it is alternate to local stack memory, and overflow that we know already. When the data is out of buffer size, it overflows. So we can write on the buffer. Let me show you what is buffer. Buffer is typically a temporary data storing system, data storage. And if the value of, well, we can download the code for this, and I already did that, and let me just show you. From here, download the source code, and then we will see, just to show you the real concept of the code. Here basically the code shows that the input data size is 5, the memory allocated for saved variable is 5, and a saved variable value, if we can somehow change this value, then we will win and we will get the flag. And or else then if there is no flag, there is no flag for you, it just will be shown. And here is the loop for the uh, um, switch cases, and when we insert the switch case values, then it just shows stuff this if switch, here is the switch, so it will print the value, write the buffer, write in the buffer, look for save value, and in case we win, then check win, or else it will remain like that. So now let's show you how it's done. Here, let me just print the heap first. The value is pico and the save variable is pico, so we need to change this one. As we know, for each bit this is in hexa address value, so for each there will be 16 bit for each character. So from B0 to D0 we have 16, and then another B0 to C, B0 to B9, then C0 to C9, then we will come to D0. So if somehow we can insert more data in the buffer, then the buffer will take some data from put some data in this one and the some in this one. So let's just see if we can interact with the buffer, change the buffer value. Like if I just put some random values here and press enter, and then let's just print the heap. So as we can see, the value just came in the first heap's data, not the second one. So we need to put even more values in the second in the buffer. So let's just put a lot of A's here and then enter, and hopefully this time let's just see the print heap. No, still not. So we will need to put even more A's here. Again, is insert in buffer. We can put any data if whatever we want. Now let's put enter. Okay, now let's see again the buffer. So as you can see, here are some data on the top and some came in the second one. So we have successfully changed the value of the save var, right? So save var is now containing this. So now we will be able to see the flag. Here is the flag. So this is a very short and yet very tricky question that we need to understand what is the binary, how the heap stores the data dynamically, and how the buffer should be overflowed and stuff like that. So this one is the heap 0, and moving on we will do format string 0, then web decode, and so on, each of them. Okay, bye.